Hi everybody. So I am going to describe how we find the quadratic equation or function for this particular problem. Our example number 1 has something to do with patterns 1 through 4 with corresponding tiles 10, 18, 28, 40. So pattern 1 corresponds to 10, 2 corresponds to 18, pattern 3 corresponds to 28, and pattern 4 corresponds to 40. But I believe you are more familiar with this type of problem when it's presented. It's presented horizontally. So I just need to call your attention to this form that you're familiar with, and that it means exactly the same thing as this table presentation here. So if I put this in sequence form, we're going to have 10, 18, 28, and 40 as a sequence. And pattern numbers would go up here 1, 2, 3, and 4. And of course, we could write this as U of 1, U of 2, U of 3, U of 4, and the other numbers to the right would be simply U of n. And we're also using the formula in order to write our version of the formula. We have U of n equals a times n squared plus b times n plus c. And we use the three other formulas starting with 2a equals the second difference. I'm just writing it here so you remember. And we know now that if you write 2a equals to second difference, that means that we need to verify whether this sequence is really quadratic. So let's do that. So we subtract 10 from 18, which gives us 8. 18 from 28 gives us 10. 28 from 40 is 12. And looking for the second difference, we subtract 8 from 10 is 2, 10 from 12 is 2. So that verifies that this sequence is a quadratic sequence. And our second difference is 2, so we write here 2. And dividing both sides by 2 because we want to get rid of this 2 in front of a. So we divide it by 2 on both sides of the equation. We cancel this out, so we have a equals 2 divided by 2 is 1. And then we have the other formula, 3a plus b equals u of 2 minus u of 1. Substituting the value of a into this equation, we have 3 times 1 plus b. U of 2 is 18 minus u of 1 is 10. So we have here 3 times 1 is 3 plus b is equals to 8. 18 minus 10 is 8. And then subtracting both sides with 3, we end up canceling 3 and minus 3 and have b is equals to 8 minus 3 is 5. So we only need to now look for c. And we have the other formula as a plus b plus c is equals to u of 1. And substituting 1 for a here and 5 for b plus c equals u of 1 is 10. 1 plus 5 is 6 plus c equals 10. And we want to get c by itself, so we subtract 6 on both sides of the equation. This cancels out, so we have c equals 10 minus 6 is 4. Now we substitute all the values of a, b, and c into this formula, so we have u of n equals a4, a is equals to 1, so we have 1 n squared plus b is 5 n plus c is 4. And at this point, we're going to write it in the standard form that you're more familiar with, the standard form of the quadratic equation. So we will change u of n into y equals, we don't need to write that one. So we just change all these n's with x. So x squared plus 5x plus 4. And this is our quadratic equation that we're looking for. So you box it, and there you go.